This is lesson 4.2, greatest common factor. We'll start with the definition. The definition of greatest common factor is the largest number that is a common divisor of a given set of numbers. In other words, it's the largest number that will divide into a set of numbers. We'll start by finding the greatest common factor of 24, 60, and 36. We'll use three different methods on doing this. First, we're going to do it by listing the factors. So we're going to list all the factors of 24, 60, and 36. First 24, which is 1 times 24, 2 times 12, 3 times 8, 4 times 6, and 5 doesn't go, and then you're back to 6 again, so that's all for 24. So factors of 60, 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7 won't go, 8 won't go, 9 won't go, and you're back to 10 here. So anyway, that's all the factors of 60. So now 36 is 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 won't go, but 6 times 6. So that's the factors of 36. So now listing all those factors, the factors of 24 again are 1, 2, 3, 4, 6, 12, and 24. 60, 1, 2, 3, 5, 6, 10, 12, 15, 20, 30, and 60. And 36, 1, 2, 3, 4, 6, 9, 12, 18, and 36. So now we're going to begin by circling all the factors that they have in common. And we know that 1 they have in common. Oops. Alright, let's try that again. 1 they have in common. Good. 2 they have in common. 3 they have in common. They also have, let's see, 4 they do not, 5 they do not, 6 they have in common, and 12 that they have in common. And I believe that's it. So the greatest common factor will be the largest number that they have in common, which in this case is 12. So 12 is the largest number that is the divisor of 24, 60, and 36, or the largest number that will divide into 24, 60, and 36 evenly. Alright, that's finding the greatest common factor by listing the factors. Now let's do it by prime factorization. We'll start with 24. So 24, again, I always like to start with the lowest prime number to keep things orderly. In this case, 24 divided by 2 goes 12 times. 12 is divisible by 2 6 times, and 6 is divisible by 2 and 3. So now we're down to all prime numbers. So the prime factors of 12 are 2 times 2 times 2 times 3. Okay. Next we'll go 60. 60, again starting with 2, goes 30 times. 30 is divisible by 2, goes 15 times, and 15 is divisible by 3 and 5. So then 2 times 2 times 3 times 5 are the prime factors of 60. And 36, again with 2, goes 18 times. 18 divided by 2 goes 9 times, and then 9 is divisible by 3 and 3. So our prime factors are 2 times 2 times 3 times 3. So now, if we list all those factors, now we have to group what they have in common using the prime factorization method. So we'll group these. They have these 2's in common. Again, they have to have all 3 in, or they have to be in all 3 groups. So, and there's that. And I believe those are the only 3. Because 2, there's no more 2's, there's no more 5's, and there's no more 3's. So 2 times 2 times 3 should be our greatest common factor. Again, that's 2 times 2 is 4 times 3 is 12. So 12, again, that's what we found earlier as our greatest common factor. Okay, now let's do it by using upside down birthday cake. Again, starting with our lowest prime number, 2, they're all divisible by 2. So that goes 12 times, that goes 30 times, and that goes 18 times. Again, these are all even. So again, 2 will go. 2 goes into 12 6 times, 2 into 30 15, and 2 into 18 9. Okay, since 15 and 9 are odd, 2 won't go. So now let's go to 3, and 3 will go into all 3. So 3 into 6 2 times, 3 into 15 5 times, 3 into 9 3 times. Since we all have prime numbers down here, we know that we've divided as far as we can go. So again, multiply everything on the left over here together. We end up with 2 times 2 times 3, and again, greatest common factor is 12. So that's showing you 3 different methods on finding the prime or the greatest common factor of 24, 60, and 36. So let's do a couple of examples here. We'll do it a couple of ways. Again, listing the factors is a tough way, especially when you get larger numbers. So I would recommend either prime factorization or the birthday cake method. And I'll do these both ways, starting with prime factorization of 12 and 30. 12, let's see, 2 and 6, and 2 and 3. So we've got 2 times 2 times 3. 30, 2 15 times, and then 3 and 5. So you have 2 times 3 times 5. Again, group what they have in common. So 2 times 3, so 6 is our greatest common factor using prime factorization. So now let's try it with birthday cake and see if we come up with the same solution. So again, starting with your lowest prime number, in this case 2, we'll go 6 times and 15 times. 2 won't go into 15, so we got to move to 3. 3 will go into both 2 here and 5 there, and that's as far as we can divide. So we multiply those two numbers together, and again we have a greatest common factor of 6. We'll see if we have enough room to do 3 here. Let's move this up. So 16, 32, and 40. Alright, we do prime factorization first. So 2 times 8 is 16, 2 times 4, and then 2 times 2. So you end up with 2 times 2 times 2 times 2 is 16. 32. 2 goes 16 times, 2 goes 8 times, 2 goes 4 times, and 2 times 2. So you get 1, 2, 3, 4, 5 2's. Okay, and then 40. 2 will go 20 times, 2 will go 10 times, and 2 and 5. So we've got 3 2's and a 5. Okay, so now we've got all 3. So again, group what they have in common. They've got 3 sets of 2 in common, and I believe that's it. So the greatest common factor of 16, 32, and 40 is 2 times 2 is 4 times 2 is 8. So 8. So let's try birthday cake, see if we come up with the same solution. We'll move up here to do that. Okay, so 2 will go 8, 2 will go into 32 16 times, and 2 into 40 goes 20 times. Again, still even, so 2 will go into 8 4 times, 8 and 10, again even. 2 will go 2 times, 4 times, and 5 times. So I believe that's as far as we can go. There's no other prime number that go into all 3 of those. So again, multiply all 3 of these together, and you get 2 times 2 times 2, which is 8. And that concludes the lesson on finding the greatest common factor.